Okay, all right. Good evening, guys. I hope everyone is doing well. So, we have been discussing about SQL in this week. Today, all right, as part of SQL course, today we are going to discuss something called as constraints. All right, something called as constraints. Okay, constraints. So, what do we mean by constraints, first of all? In English, there are many words to represent constraints in English. Okay. Some people say constraints means limitation. All right. Constraints means limitations. Okay. It can also be called as, sometimes rules, okay, and restrictions. All right. Restrictions. So these are other words which will specify the meaning of constraints. What is the purpose of constraints? Why do we study about constraints in SQL? That is the first thing we need to understand. All right. Constraints, all right. Constraints helps us maintain the database properly. To be honest, for example, if I create a table, all right, when I create a table, let's assume that there is a column in the name of age. All right. What usually we will do after the column name, we will declare the data type of this particular column. Assume that it is integer. Column name is integer. Okay. Column name is integer. After this, I can specify the constraint. Okay. I can set some rules to this particular column, which has to be practiced, right? Whoever the person who enters the data into this particular column, right? Whoever the person is, okay, he has to follow this constraint, whatever the constraint is, whatever the limit that has been set, right? That limit has to be, or however you call it, you can call it as a limit, or you can call it as a rule, or you can also call this as a restriction. Okay. This has to be followed when the data is being entered. All right, this data is being entered. Now let's assume, no need to assume. Okay, for example, look at this here. The data type of this column age, right? The data type of this column is integer. Let's assume that there is a person, okay? This person enters the data in the age column mistakenly. Okay, actually the data type is integer here. Even if he tries to give the data in the form of numbers, in the form of alphabets, for example, the actual age that has to be specified here is, for example, 12. This is the actual expected input that has to be given in this column. Instead of this 12, if he types 12, all right, if he types 12 in this column, that will throw error saying that data type mismatch, saying that data type mismatch. All right. So the ultimate purpose of using constraints is to maintain the data type, as well as, generally this is called as, okay, integrity and consistency of the table or database, however we can call it. All right. However, so these constraints are used to, okay, to maintain the data type or data type of in the table or data type in the database. All right. This is the main purpose of the constraints. There are different types of constraints that we have got. All right. For example, there is something called as not null. Right. There is something called as default, and there is something called as unique, and there is something called as primary key. All right. Foreign key, check, index. Apart from these constraints, there is one more constraint which is called as on delete. Okay, on delete. Within this on delete, there is something called as set null. All right. Another one is cascade. Set null and cascade. So today what we are going to discuss is we will theoretically understand what is the purpose of not null constraints. I mean, what is the purpose of not null, where to use not null constraint, what as well as default. Okay, what is the application of all these constraints and where to use this, how to use this. Theoretically we will discuss and we'll try to understand how to take advantage of these constraints. Okay, I said that constraints will help us maintain the database, right? That means to maintain the same type of data, right? The say other type of, if I declare that age is equal to integer, all right? If I say not null here, if I say not null here, for example, let me write the complete code so that you will have a clear idea. Create table name is let's say table name is marks. Table name is marks. All right. So my first column name is English. First column name is English. And the data type of this column is float. All right. The data type of this column is float. Followed by this data type. Here I have to specify the constraint name. Whatever the constraint is, here I have to specify the constraint name. All right. Now I will take this not null constraint. I will specify here not null. I will specify here not null. What happens when I specify this English column is not null? Okay, what do I mean by this? That's what we are going to discuss now. When I specify a column is a not null column, you know, what does that mean? That means a person who enters the data into this table, right? A person who enters the data into table, he cannot leave this particular column empty. For example, when I enter the data, insert into marks, okay, values. Assume that I got a multiple columns here. Max equal to max is float, and I'm not specifying any constraint here. For now, I'm taking only not null constraint. All right, not null. And maths, it's a data type is float, and then science. Science data type is also float. That's it. Only 3 columns. All right, only 3 columns. Values. When I say values, all right, when I say values, I have to input all the values. Okay, I have to type all the values here. If I want to type or if I want to give the value for this column alone, all right, if I want to enter the value for this column alone, in that case, what I have to do here is I can directly specify marks of maths, then values comes here. Whatever the value is, I can specify the value here. For example, I will take 100. When I say 100, when I execute this particular value is going to be stored in this particular cell. All right. Okay. Now, if I want to, I'm going to enter all the values of these columns. So I'm not going to write in this manner. I can directly specify all the values here. If I simply leave this empty, assume that I am simply leaving this as empty. I'm not filling this value. And then instead of that, if I say null here, okay, even if I do not specify anything, what happens? That is the thing that we have to understand here. Null, okay, maths mark is 79.7, for example, and then science mark is 80. All right. I have specified here that this particular column must be not null. That means this column cannot take null values. That is what it means. All right. That means a null value cannot be entered. That means this column cannot be empty when I am inserting a details in this particular table. That is what it means. If I run this command, all right, if I run this query, it will throw error. It will throw error saying that, okay, it will saying that constraint has been violated. Okay, constraint has been violated. This will be the error. What is the reason behind this error? The main reason is the first value that I am entering here, right? This is for this English column. Okay, English column. Here I cannot enter null value, or this cannot be empty either. This cannot be empty either. The constraint will not allow us to enter, okay, a null value. That is the point here. So that is the purpose of using not null. Okay, the not null constraint will not allow us to enter the null value. If I type 80 here and if I run this, then I will not get this error. This record will be inserted into the marks table. All right. This particular record is going to be inserted into this mark table. So this not null constraint will not allow us to enter the null value. That means the English column will not take null values. That is what it means. All right. That is the application of constraint, not null constraint. Okay. Just like that, we also have a lot of other constraints. For example, default, okay, unique, primary key, foreign key, check constraint, and index. These are all the other constraints that we are going to discuss in this session. All right. Now we discussed the not null constraint. Okay, we discussed the not null constraint. Let's try to let me give you a small example. Quickly give me a let me give you a quick example of this. Let me open my workbench. Just a moment. Yes, perfect. Don't want to save this now. Don't save. Don't save. All right, I don't need. All right. So I will quickly use one use class. All right. Now I will create a table. I will create a table now. Create table. My table name is going to be mark. All right. My table name is going to be mark. My first column is going to be English. The data type of this column is going to be float. And here then I have to specify the constraint name. Here I will say not null. Look at this, not null. My second column name is maths. All right. And then this is going again, it is going to be float. My third column name is going to be science. Again, it is going to be float. So this is my table name. Now I have successfully created my table. I have successfully created the table. Now I will try to insert the data into it. Insert into mark. All right. Values. All right. Now, if I say null, okay, if I say null here, look at this, see what is going to happen. Null and 45.89, 598 and 98 point something. If I run this, it is going to throw error. Look at this column English. Look at this column English cannot be null. All right, column English cannot be null. If I change this to any other value, all right, for example, 90. If I run this, now one row affected. This particular row has been inserted into this mark table. So this not null will not allow us to enter the null value. Even if I simply leave this, okay, even if I simply leave this, all right, then it is going to throw the error. All right, it's going to throw the error. All right, now we can go to the next. Now we can go to the next constraint. All right. Our next constraint is default. What is this default? All right, we know what is the meaning of default in English. Okay, right? Isn't it? We know what is the meaning of English. So when I specify default, right? For example, I will say age column, right? The integer is going to be my data, right? Data type is going to be integer. After this, I will specify my, all right? After this, I can specify my constraint. Here, I will specify default. Here, I can specify my default. If I what is the default age that I'm going to give here is 18. Okay, the default value that I'm going to specify here is 18. All right. Now what happens now? When I specify default, that means if I do not provide null values to this particular column, I'm sorry, if I do not provide any value, right? If I do not provide any value to this particular column, then this 18 is going to be stored in that particular record or in the particular cell. All right. If I do not provide any value to this age, all right, then 18 is going to be stored in this column. All right. That is the application of this default constraint. All right. When something is not provided, then the default value is considered to be inserted for the insertion. That is the application of this default constraint. Okay. All right. Now let's, okay, we will theoretically discuss this one by one, and then if we have a sufficient time, then we will discuss about the answer. This is the application of default constraint. The next one that we are going to discuss is unique constraint. All right. The next one that we are going to discuss is unique constraint. What is this unique constraint? Okay. This unique constraint. Okay. This unique constraint will not allow us to enter the duplicate values, or I can simply, I will rephrase this, will not, okay, the unique constraint this unique constraint prevents the duplicate entries. All right, this unique constraint will prevent the duplicate entries. That is the application of this unique constraint. Okay, how to declare this? The same format: column name followed by the column name. I have to specify the data type, followed by this data type I have to specify the constraint here. Okay, I have to specify the constraint. For example, if the, let's assume, for example, Aadhaar number, for example, right, Aadhaar number. Data type is going to be integer only. For example, I will say big integer. I will say big integer here. All right. The constraint that I am going to use here is unique. If I try to enter the same Aadhaar number 2 times, if I try to enter the same Aadhaar number 2 times, then it will not allow us to enter the duplicate entry first of all. I mean, that means when you try to insert that duplicate entry, it will throw a message saying that this particular entry is already available in the table. All right. So this will not take the duplicate entries. This will avoid the duplicate entries. That is the application of the unique constraint. Okay, that is the application of unique constraint. Another interesting point in this unique constraint is in the back end. Okay, in the back end, an index in MySQL. All right, in MySQL, if you are using MySQL, in the back end, an index will be assigned. In the back end, index will be assigned to this particular column. When you specify a constraint is a unique constraint, right? In back end, to this particular column, index will be assigned. All right, not only unique primary key, all right, foreign key, index, to all these constraints. When you are using all these constraints, if you use any one of these constraints, in the back end, an index will be assigned to a column in which these particular constraints have been used. All right, wherever these constraints have been used, right, in the back end, index will be assigned to that particular column. All right. So this is our unique constraint. What is unique constraint? Very simple. This will not allow the duplicate entries. Simple. All right. The next one is going to be the primary key. All right. The next one is going to be the primary key. What is this primary key? Very, very, very important constraint, very important constraint. Maybe we can say that without primary key, all right, without primary key, a lot of operations that are happening, all right, that are happening in the database cannot be performed. This is a very important key, because the best example is, again, even this primary key, all right, even the primary key will also not allow the duplicate entries. This also prevents the duplicate entries. And another important point is, it prevents the duplicate entries, all right, prevents duplicate entries. Prevents the duplicate entries. That means each row, each row of this column, all right, wherever the column that has been declared as a primary key, right, that particular column, okay, all the rows of that particular attribute must be unique. Must be unique. That means I'm not saying that it should be unique. Unique in the sense, each entry must be different from one another. Each entry must be different from one another. You cannot, okay, the standard practice here is, you cannot apply the primary key on all the columns. This can be applied only on the column that is going to take unique values, different values. All right, identical, not identical, unique, different values. The best example is your employee ID. Each employee ID will be very unique, right? Each employee ID will be very unique. For example, if my employee ID is 4026, then another employee ID will not have this same employee ID, right? The another employee ID will not be the same. Obviously, it will be different. By default, it should be different, isn't it? If this is 40026, then the next employee ID must be 40027. Employee ID, and then mobile number, okay, mobile number, or even it could be an Aadhaar number or PAN number. All right, you can use this if you want. All right, if you want, maybe you can use this as a primary key if you need it. All right, okay, this is called as primary key. This will not allow us to, this will prevent the duplicate entries, first point, which means each row must be unique, different from one another, right? And then even for primary key, index will be assigned in the backend. All right, index. For example, if I say employee ID, my employee ID is going to be the here integer. Maybe I can say, let's say the data type is going to be the varchar. The data type is going to be the varchar, and it is going to be the primary key. I can specify it here. I can specify this here. If I, all right, if I say it is a primary key, in the back end, the employee ID column will have an index attached. This will have an index attached. Okay. Okay. This is a normal primary key. This is a normal primary key. And there is something called as composite primary key. Composite primary key is nothing but I can also specify multiple columns as a primary key. I can also specify multiple columns as a primary key. How to define that multiple column as a primary key? Let me give you one example. I will create a table, create table, okay, create table. Maybe the table name is going to be employee, for example. employee details. All right, that is the table name. The first column is going to be employee ID, and it is going to be a varchar. All right, it is going to be a varchar. And the name, the next one is going to be the employee name. Employee name is also going to be the varchar. I will specify the number of characters here. Maybe I will say maximum digit of employee ID is going to be 8 digit, for example. Varchar, and employee name is going to be 20, for example, and then designation or title. Okay, designation or title. This is going to be the next column. Again, this is varchar. Here, again 20. The last column is going to be the mobile number. Okay, mobile number. This is going to be the big integer. All right, this is going to be the big integer. Now, if I want primary key, if I want any one primary key, then I can directly specify here as a primary key. If I want two columns, any of the two columns to be primary key. All right, any of the two columns to be primary key. How can I do that? How can I do that? That's what we are going to discuss now. Look at this. Here I can specify primary key, comma must be here, primary key, and then, all right, and then here I can say the columns, I have to specify the number of columns to which, okay, which has to be, considered as a primary key, right? I will specify the column names here. For example, I will take employee ID and mobile number. Maybe if I try to apply any, for example, functions, retrieval, right? During the retrieval, okay, when you try to retrieve the data, okay, from the database, these primary keys will help a lot. This will increase the performance. All right, this is going to enhance the performance. The speed, processing speed will be increased if you use the primary key. That is the another important point here. All right, now I want these two to be a primary key. So I will specify here employee ID and then mobile number. All right, employee ID and mobile number. All right, these two columns, both the columns will work as a primary key. All right, both columns will work as a primary key. All right. The advantage here is, for example, for same employee ID, for one employee ID, I will give one mobile number. Let me tell you this. If I say, all right, if I say, all right, if I say 400, for now, actually, I have specified 8 here. For the easy explanation, I will take 4001. Sorry, 40,001. If I say 4001, right, then if I give mobile number as 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. All right. We discussed that each employee ID, if it is a primary key, each key must be unique, right? The same thing works here. For the same employee ID, all right, for the same employee ID, I can give another mobile number here. another mobile number can be given here. But look at this. These two looks like a duplicate. Actually, how computed the SQL server thinks here is quite different. Both of these entries, all right, must be duplicate. Only then it is considered to be a duplicate entry. For example, if I instead of this entry, if I write 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. If I enter this entry, first entry will be entered. If I try to insert this one, then since it is identical, it is going to throw error saying that it is a duplicate. But if I change the last value alone, that will make this entry unique. Now it can be inserted. All right. So this type of this type of primary key is is heavily used in to create the many to many relationships in database. All right. It is also used to create many to many relationships in database. All right. That is the application of the primary key. And the next one is foreign key. What is foreign key? All right. What is foreign key? This foreign key is nothing but, let's assume I have got two tables here. I have got two different tables. This is your employee table. This is your employee table. And this is your, for example, let's take, this is a branch table, for example. Okay, this is a branch table. Now here is one table. Okay, this is a branch table. The first one is a primary key. This is also a primary key. And this table in the first key, employee ID, right? This is branch ID. This is employee ID. All right. This is also a primary key. But this is a different table. This is a different table. All right. This is a different table. This is a different table. All right. If I refer this branch ID, this primary key over here, for example, this employee table consists of details of the all employees, no matter whether he is a CEO, manager, director, whatever it is. All the employee details will be mentioned here. Okay. And in which branch this employee is working. A company might have multiple branch, right? In Chennai, Mumbai, all right, or Bangalore, whatever the branch is. An employee may work in any of these branches, all right. So instead of writing the name of the branch, okay, Chennai, Mumbai, instead of writing the name of each branch, it is the standard practice here is the code. For example, branch ID 1, branch ID 2, branch ID 3. Okay, Chennai, Mumbai, and Bangalore. Instead of writing Mumbai, if I refer this column here, all right, if I refer this column here, as for example, if this particular employee is working in a Bangalore branch, I can specify 3 here. All right, I can specify 3 here. If the second person is working in the Mumbai branch, I can specify 2 here, and it goes on. It goes on, right? So this is called as establishing the relationship between a table. All right, this foreign key is heavily used. This foreign key is used to establish relationship between tables. Okay, this foreign key is used to establish relationship between tables. So this is the important one. Okay, this primary key, foreign key, very two important constraints. Without these two, okay, foreign key is nothing but when one primary key is referred in the another table, right? This primary key, this is also a primary key, but this primary key doesn't belong to this table. This primary key doesn't belong to this table. This primary key belongs to this table, right? So this key is called as foreign. This key is called as foreign key. All right. To this table, this primary key is foreign, like an alien, right? Because when I create table, I will not specify this as a foreign key. This is going to be a normal column. This column has to be created when I am creating the table. Okay, but it is not going to be a primary key. We will establish a relationship between this particular column to this particular column, not column, row wise. All right, this is like a one-to-many relationship. Okay, this is called as one-to-many relationship. So that is the application of this foreign key, right, to establish the relationship, especially this type of relation when you are performing joins. All right, when you perform joins and even when you perform subqueries. All right, subqueries and these things. All right, this foreign key is going to play an important role. If two tables are not linked using foreign key, then you cannot directly even joins. Instead of joins, even you can use where class, but still, okay, but still a lot of things are there, challenges are there when you are using when you try to perform join using where class. All right, so it is better to have a foreign key when you are performing joins and subqueries. All right, it's going to be very, very useful. So if you are performing joins and subqueries, then if you have a foreign key, that's going to make your job easier. That's going to make your job easier. So the main application of foreign key is to establish the relationship. All right, and the next one is check constraint. The next one is check constraint. The name, look at this, the word itself gives us some clarity, isn't it? The word itself gives us some clarity. Okay, check means what? We know what is the meaning of check, right? We will check something. This word, even uneducated people are using this type of English words nowadays, right? So check means we are checking something, right? So what is this check constraint, right? What is this check constraint? When I use this check constraint is used to all right, check constraint is used to validate the condition. Validate the condition. Okay, check constraint is used to validate the condition. If the condition is satisfied, only then that particular entry is going to be stored in the database. Otherwise, it is not going to be stored in the table. All right. Let me give you one example for this. Create table. Table name is going to be, for example, employee. Let's take employee. Employee ID. This is going to be a varchar of 7 digit, and this is going to be my primary key. Only employee ID is the primary key. And then employee name. Again, this is also going to be the varchar. And I'm not going to specify any constraint here. Maybe if you want, you can specify not null. Sorry. Not null. Maybe I can specify not null here if you want. All right. For now, I will proceed further. Employee name, and then what else? Employee ID, employee name, designation. Again, designation is also going to be the varchar of 20. And then age. All right, age. I will specify age is integer. Now I will add my constraint here. Okay, now I will add my constraint here. My constraint is check. Okay, check if age is greater than 18. All right, check if age is greater than 18. If the age is greater than 18, all right, now this is the constraint. This is how I can use the constraint here. Check age is greater than 18. All right. Now, when I try to insert the record into this table, insert into employee. All right, insert into employee. Values. All right, values. Now, employee ID is going to be something, and employee name is going to be XXX, and designation is going to be, for example, data scientist. And age, if I specify 17 here, this entire record will not be inserted into this table because we have specified the condition here. We have specified the condition here. All right. What is the condition here? The age has to be greater than 18. If the age is greater than 18, only then this record is going to be inserted into this table. Otherwise, it will not be inserted. So this condition, okay, is validated here. I mean, the validation happens here. Okay, if the condition is correct, only then this record is going to be stored in the table. Otherwise, it's not going to work out. Simple. Maybe if I say 19 here, no problem because it is greater than 18. All right, it is okay, it is greater than 18. Obviously, it's going to be inserted. Now, the age must begin from 18. Now, what should I do here? Very simple, greater than or equal to. The age is greater than or equal to 18. Now, even if I put 18 here, okay, this will work now. So, this is the application of this check constraint. All right, this is the application of the check constraint. All right, this condition is going to be validated. If the condition is a valid condition, if the value you are entering, right, if this value meets this condition, then the entire record is going to be stored in this table. Otherwise, it is not going to be stored. That is the check constraint. All right, that is the check constraint. The last one that we are going to discuss now is index constraint. All right, index constraint. What is the purpose of this index constraint? All right, when the database is very big, when the database is very big, right, the retrieval, right, the retrieval, Okay, the retrieval will take some time. Okay, the data retrieval will take some time, maybe depends on the server. For example, it may take 5 seconds to 10 seconds. Okay, 5 seconds, 10 seconds, depends on the size of the data. All right, it depends on the size of the data. All right, database, and depends on the size of the table, number of records, right? It may take 5 seconds or 10 seconds. Even if it is a very big data, all right, it may even take 15 to 20 seconds. All right, sometimes it may also take 1 minute to 5 minutes. How to reduce this time delay? All right, how to reduce this time delay using this index constraint? If you use this index constraint, all right, there is a huge, this will increase the performance. Okay, it will increase the processing speed. All right, it is going to increase the processing speed. That is the main application of the index constraint. All right, that is the main application of the index constraint. All right. So these are all the constraints. Okay, in the same way, all right. In index, there are different types of indexes are there. Right, there are different types of indices are there. All right. So now maybe I can say, for example, index. Other one is unique index. There are there are many types of indexes, but now we are going to discuss only these two types of indexes. All right. One is called as index, other one is called as unique index. This index will accept the duplicate values. This unique index will not accept the duplicate values. That is the important point here. This index, right? This can take the duplicate values. Duplicate values are allowed here, whereas here duplicate values are not allowed. All right, duplicate values are not allowed. When I apply, let's assume there is a table. All right, there is a table. All right, and I'm creating a table in MySQL. Okay, in this table, employee ID, okay, employee name, and there are a lot more details are here. All right. Assume that totally I have got 2 lakh records. Totally I have got 2 lakh records. If I try to search based on the, assume that I want whose name is Suresh Kumar, for example, whose name is Suresh Kumar. How many employees are there in the name of Suresh Kumar? I want to identify that, for example. I will use this, maybe I will do like this. I will write a query just like this, where employee name is equal to Suresh Kumar. So all the details will be fetched to me, right? At that point of time, this may cause a delay, maybe 2 seconds or 5 seconds. All right, whatever the delay is, this may cause a delay. But if you apply index on this particular column, if you apply index logic on this particular, create an index for this column. All right, you can create an index, for example, in the same way, create index name, okay, on table name and column name. Table name and create index name on table name within bracket column name. You can also specify multiple columns here within this bracket. That can also be done. All right. So if I execute this, an index will be created, an index will be assigned to this particular column in the backend. After applying the index, if you run this command, then you will see significant improvement. You can see significant improvement in your processing speed. All right. So these are all this is the main application of the index. In the same way, you can also create unique index name. You can give any index name. That's not at all a problem. Here I am directly specifying index name. Maybe you can give something like a name index, for example, name IDX. This is the index name. If you give a name to an index, when you are deleting it or when you are altering this index, you can directly use this name. All right, you can directly use this name in the future purpose. So this will make our, to handle it in future. Okay, if you want to handle, if you want to do something, if you want to do any modifications on this particular index, and if you give a name to that index, then based on this name, you can perform any modifications. All right. So create unique index name on, again the same logic, same syntax comes here. Table name and column name. Okay, so it is so these indexes are mainly used to increase the performance. All right. So these are all some constraints, some useful constraints that every SQL learner must learn in the beginning. All right. These are all the constraints. Let me revise these constraints in one line. This null constraint will not allow us to enter the duplicate value. All right. This default constraint will enter the default value when I am not providing any value to that particular column. Again, this unique constraint, all right, this will not allow the duplicate entries. All right, this will not allow the duplicate entries. Along with that, in the back end, an index will be attached to that particular column in which unique constraint has been used. The same index logic goes with primary key and foreign key also. So primary key is used to identify each record of the table. All right, it is used to identify each record of the table uniquely. That is the main application of the primary key. Along with that, an index will be attached to that particular column. All right. So the same, when you are referring the same primary key in another table, then this one is called as your foreign key. So this foreign key is majorly used to establish the relationship between two tables. This check constraint will validate our condition if the data that we have entered, if that particular data meets the condition, meets the criteria, then that particular record is going to be inserted into my table. Otherwise, it will not be inserted. This index you can create index on any column. Okay, you can create index for any column. Once the index is applied, okay, so this will increase the performance, right? This will increase the performance significantly. All right. So these are all the constraints that each one should be aware of. So the syntax here is very simple to specify the constraint. The standard syntax is column name. Okay, column name followed by the column name. Here I will specify the data type. Followed by the data type, I can specify the constraint. I can specify the constraint. Create table name, whatever your table name is. You can specify any number of constraints you want. All right. Okay. So this is the constraint, guys. I hope this will be very, very useful for you people. All right. So by tomorrow, we will discuss the next topic. All right. Or the hands-on part, whatever. All right. All right, guys. So thank you. Thank you for your valuable time. Okay. So I hope this will be very, very useful. Make use of this content. We will meet once again tomorrow and we will discuss the rest. All right.